All right, we are live now. Hey, hello everyone. I know it's a little bit late than we normally do these calls, but very, very good to see you guys. Hey, John, Jesus, who else is here? Kevin. Hi, everyone. There's more people around, so if you can hear me fine, if you can see me fine, say hello. We are one more presentation here at the Career Week, right? So we're having lots of fun in the career week before the end of the year. So John says he's really nearly ready to dazzle. Okay, that's cool. Hey, John. So hi everyone, can you hear me? So you should find the chat on your side. So go into chat, say hello if you can hear me. If the sound is good, if the if the audio is good. David is already here with us, and he's going to start in a minute. I don't see anyone saying anything. So, all right. So, okay. All right. Everything works well. Thanks, Kevin. Thanks, me. All right. Excellent. So, we're going to start in a minute, and we're going through this several presentations this week that are discussing things that you can do in your career, technology that you can do in your career. In a way that you prepare for next year, right? So it's a good time for us to be discussing next year, right? So hi, Aaron. Hi, Joaquin. How's everyone? It's amazingly good to see you all, and it's great for having you all here. We are remember that all the videos for this week are available. So you should have received an email with all the videos. We recorded the two that already happened. We're gonna do two more tomorrow and Friday, and so you have all the links for all the videos, so you can see at any time that you want. Right? We don't have a whole lot of people here today, so we want to make this very, very interactive. So find the chat, ask questions. So let me ask you, where are you from? I know John is from Australia. So where everyone else is from, right? So just so we can get started. Actually, our guest here today, David Buck. Are you? Where are you from, David? Are you American?
Yes, I'm American.
All right. So David is American, but he lives in Japan, right? So for him, it's like 7 o'clock in the morning. He didn't go to sleep yet. He's ready here to get to rock and roll, right? So Rio de Janeiro, Brazil, Spain, living in London, Germany, Jacksonville, Sweden. Cool. Well, actually, I just told David that I thought the guys from Europe would not show up because it would be too late. But actually, we got a lot of people from Europe. So thanks a lot for all of you being here. So Miguel is from Venezuela, living in Ireland. Okay, very cool. So hello, Joaquin. Hello, Travis. Jacksonville, Florida. Nice. Okay, so say hello to the Jacksonville user group. I was there not long ago. It's a great place. So Eol is the leader from Jacksonville user group. So it's pretty cool. All right. Okay, so no further ado. We have today a very, very special guest. So basically, the top most important open source project around the Java world is the JVM itself, right? It's a project that contains not only the JVM, but all the base libraries that we use, everything all the tools, the compilers and everything that we use for developing Java. So that is OpenJDK, right? So it's a great pleasure to have here a good friend, David Buck. David Buck is from Oracle. He's one of the OpenJDK experts, and he's going to talk here with us about how you can contribute to OpenJDK and kind of give us a general overview of the project and everything. So, David, hello. How are you doing, man?
Hi, Bruno. Doing pretty good.
Okay, so David is going to share his screen and not his camera, right? So I'm just going to transfer for him. So, David, it's with you, man. Go ahead.
All right, so let's see if I can get my screen sharing going on here. Everyone just ignores seeing a horrible Windows desktop for a second.
That's not a problem.
Okay, so can people see the Ubuntu desktop and my slide here?
Yeah, we can see. That's fine. See, it's perfect.
Okay, great. Well, we'll go ahead and dive right into things. So first off, I'd just like to say thank you for inviting me to do this presentation. This is content that I originally delivered at Java 1 this year, 2017. And unfortunately, the format was 45-minute sessions this year, which is just, quite frankly, way too short of a chunk of time to kind of talk about such a huge project as OpenJDK. So I'm really thrilled and excited to have an opportunity to kind of do it as it really should be done, and spend enough time on the topic that it deserves. So I kind of figure this is probably about an hour long presentation, give or take 10 or so minutes. And that of course depends on if we get questions or anything. Generally speaking, I would appreciate most questions to be saved towards the end when we'll do a Q&A session. But if there's something that's like really super pertinent or important to what I'm talking about at that moment, please feel free to jump in on the chat and let Bruno know, and then he can kind of let me know or enter into the
All right.
conversation. So I'll
David,
start off.
Dave, let's do like this. If you have any questions, go ahead and type in the chat so you don't forget the question, and I'll hold off the questions all the way to the end, unless it's something that I see it's very, very important at that moment.
Okay, great. So anyway, I'll start off with a really short introduction. I know a few of you out there know me, but I'm a JVM sustaining engineer. So basically, my bread and butter work is fixing JVM bugs for releases that have already shipped. So specifically now that includes JDK 6, 7, 8, and so the hotspot JVMs that ship with those. And I originally came from BEA, so I originally come from the JRocket side of things before Oracle bought us. So I'm doing Twitter, I blog, I do some speaking events. That's pretty much it. So that's me. And who are you guys? So I'm not really sure what kind of audience this particular webcast usually gets, but certainly when we prepared these materials, what I had in mind was not just people who would necessarily be interested in contributing code to OpenJDK, but also what I would call an OpenJDK power user. And this means that someone who is using Java in their day-to-day work, but for whatever reason needs access to the source code to kind of do things that you otherwise would not be able to do. And kind of the textbook example of something like that would be to do your own debug builds, whether that be just the generic fast debug builds that have all sorts of insertions and stuff like that enabled, or your own custom builds where you might go in and put in debugging statements somewhere in the code or things like that to try and instrument your own builds. And those are the kind of things where even if you don't necessarily have any plans to contribute code back to the community, you can really empower yourself to be a better Java developer by having access to the code. So Bruno and I talked yesterday about kind of just one first step that we hopefully want everybody who's participating in today's call to be able to achieve, just to get the ball rolling, just to get things moving as a first step. So what we decided on was that really just getting access to the code would be a very good goal to set for everybody. So in order to do that, you need access to the source control system, and we don't use Git, but we use something called Mercurial. So what I want to start off by kind of, hopefully everyone can read this small font here, of pointing people to the resources that they need to get a hold of Mercurial on their system. So ideally, while you're listening to this, if you could follow along to the extent that you can, get Mercurial up and running on your system and use it to sync out the source code for OpenJDK. And if you're happy with that much and you're fine with not moving on, that's a really good step, and that's going to be very useful to you in and of itself. But of course, you can go further than that and continue to follow along and actually make changes to it and build it and kind of follow along with some of the demo type stuff that we're going to be doing in today's session. So if you're on Linux,
can you increase the font a little bit? It's a little bit too small.
not really sure how to do. This is just a plain text editor here. Actually, I mean, because this is really straightforward, so I'm just gonna read some of these out. So if you're on some sort of Linux, which is what I really recommend doing most of this stuff on, and I figure probably just because of this particular audience being who they are, many of you are probably on Linux already. And if you want to get Mercurial installed on Linux, it's really easy because it's a default package in the most popular distributions. So if you're on, a Debian-based system like Ubuntu, for in most cases you'll just be able to do the standard like sudo apt-get install and then Mercurial, Mercurial. So just apt-get install Mercurial will get you going on Ubuntu or other Debian-based Linuxes. And then for those of us kind of on the enterprise side of things, whether that be Red Hat or CentOS or Oracle Linux, you can do very similar yum install Mercurial. And sometimes the package name will have some funny stuff in it. So I've used wildcards here to specify the package name. But it's very easy on any of these distributions to find the Mercurial package and install it. If you're on Windows or Mac OS, the situation is a little bit different. You're going to want to download a specific installer for your particular platform. And so where you would get those from is, I didn't mean to open up Firefox. Sorry about that. I have everything planned. So if Chrome wants to play nice with me here. So you'll see here, hopefully people can see the URL here. There's a mercurial-scm.org. And that's Mercurial SCM for source code or source control management, or source code management.org. And they have a download page that has downloads for all the main installers. Actually, if you just go to Google and you just do Mercurial download, actually the link I would recommend is the second from the is the second one that will pop up on most Google searches, depending on what country you're in. And so here you'll see that these are kind of like the official downloads for various OSs, and you'll see that they have set up installers for Windows, both 32 and 64-bit, and they have a Mac OS installer. So if you're on any of those two, what we usually call a client platform, you can get Mercurial very easily for those, and it's a standard GUI installer where you just keep clicking next and agreeing to all sorts of stuff until it's installed. And the payload, so to speak, for all of these is just a bunch of command line tools that will be available to you and hopefully be automatically inserted into your execution path when you're at a shell. And that's really all you need to get up and running. That's all the software that you'll need. Everything else is pretty much will be separately identified by configure and build scripts and stuff as we go along. So anyway, so hopefully those of you that do want to kind of follow along as we're doing stuff, this is kind of the hardest thing that we'll do today is just finding the right Mercurial download and getting it up and running on your system. So maybe some of you are already there. Anyway, we'll go ahead and move on. So anyway, so the goals for today's session is basically at the end of this session, I want everybody who's interested in it to kind of have all the knowledge that they need to really dig in and start hacking. And what I mean by that, of course, is that you can get the source code, you can edit it, you can build it, and then you run it, test it, and then rinse and repeat. So you can get the classic development cycle where you can make a change, build, test, and just keep doing that until you end up with whatever end product that you want. So we'll be very focused on how to get the code, how to get the right code from the right repository, and then how to actually build it, and then how to get a change. And then once you do make a change, how you might contribute that back to the community. Also, there's people that are just interested in OpenJDK because it really is, it's what you can see the development as it's happening in real time. So it's not like we are doing, all this internal secret development within Oracle and then just release stuff towards the end of a release chain to the public. OpenJDK really is the state of the art development as it's happening. We push to the same repositories that everyone outside of Oracle pushes to, and the only exceptions to that is things like security fixes and stuff that for obvious reasons we need to keep under covers until we do an official security release. But when you're looking at OpenJDK, you're actually looking at the JDK at the absolute most latest version that anyone in the world can see. And so it's a really great way to kind of see what we're up to see what features are being added, just to see where we are. And so just to follow our progress is a really great benefit of getting to know the project better and becoming more fluent with its different processes and all the technologies that we use. So today's talk, I'm going to break into three major sections. We're going to start off with doing just kind of an overall introduction to the project itself, talk a little bit about where it came from, why it exists, and kind of lay down some basic definitions so that we're all on the same page and kind of using the same language to talk to each other about the project. And then we're going to dig into what's probably the most important part of the talk, which is the tools and technology, where we introduce Mercurial and the other tools that we use just to basically get you up and running, get you able to get the source and build it and start hacking away if that's what you choose to do. And then finally, we're going to talk a bit about process. It's a huge project with a whole bunch of different moving parts, and there's a whole bunch of different people involved, and kind of controlling all that or wrapping your head around all that can sometimes be a little intimidating if you're new to the project. And so I kind of want to ease the barrier of entry there and try and give an overview of how all this stuff works in terms of rules and things like that, so that where you can fit into that project if you want to participate yourself. So starting off with the project itself, so what is OpenJDK? It's basically an open source implementation of Java Standard Edition or Java SE. And as of JDK 7, it's also the official reference implementation. Reference implementation is kind of a strange phrase, but basically it means that it's an implementation of Java that's supposed to exemplify the specification. So there's all these different licensees of Java technology all over the world, but ideally there should be one particular implementation that's meant to almost define what the correct behavior is, and it hopefully can fill in some of the gaps that the specification might not be entirely clear about. Because as detailed as the specification is, there's always times where it can be difficult to really interpret it. And so while the reference implementation doesn't necessarily define correct behavior, it's okay to be different than the reference implementation. It does give one example of what correct behavior or what we consider correct interpretation of the specification to be. So that's very important. And up until JDK 6, that was always Sun's JDK. And as of JDK 7, it's the OpenJDK implementation. So the project itself is actually not just one project, but it's made up of a whole bunch of individual sub-projects. And we'll go through what a few of those different projects are and how they relate in upcoming slides. So why did Sun do this? There's a lot of companies out there that don't open source all of their code, but Sun chose to do that, and specifically chose to do that with Java. So there's one main reason, and that was really to push their hardware sales. At the time, Sun still very much thought of itself as a hardware company. That's where it came from. That's kind of its heart and soul, was originally making those workstations and then later servers. And so for them, Java, more than maybe a product that you'd sell yourself and try and make money from, it was more of a technology that they would use to sell hardware. And so they, I believe correctly, believed that they had the best hardware out there to run Java on. And so if Java was adopted by a lot of people and was successful, they believed their hardware would also just follow along and be successful and be adopted by everyone out there. And so to get Java to be more better adopted, they decided to open source it in order to compete with all the other different kinds of technologies that were out there. So there's actually quite a long history of Java source code being available, and that history predates the OpenJDK project, surprisingly enough. So even before the OpenJDK project, which was kind of like during the mid-noughts, 2005, 2006, 2007, when that stuff started actually happening. Before that, there was a lot of research and different projects and things going on that needed access to the JDK source code. And so Sun made that source code available to, say, universities and things like that, nonprofit organizations that wanted to use the source code for nonprofit uses. And so there was several licenses that the Java source code was made available under, but none of those were technically open source licenses like the GNU public license, for example. And so it did not meet the definition of a true open source project in any sense. It was really just something that Sun was doing to try and continue to push for adoption of the platform. And so in response to this, Richard Stallman wrote a really famous article known as the Java Trap. And basically he pointed out that you can write all sorts of open source software, but if the software that you write that's open source depends on a platform that isn't open source, then your project really isn't free. And there's limitations to how people can use your project and contribute to it. And so it's not really open source if it's written in Java. So he wrote this, and honestly, he had a very good point. And so Sun, in response to this, decided to open source Java to kind of take this away as a blocker to further adoption of the platform. So at Java 1 of 2006, they announced that they were going to open source the Java platform. And then later, interestingly enough, at Oracle Open World, that same year in October, Jonathan Schwartz, who was then CEO of Sun, said that the source code was going to be released within the next 2 to 3 months. And then in November of that same year, the Java C compiler and the Hotspot JVM source code was released. But unfortunately, with just those two components, there's not a whole lot you could do because it wasn't a complete JDK. It was really just the JVM and the source code compiler. Interesting for if you want to read the source code and learn from it, but not really usable by itself. It wasn't until later the following year in 2007 that really the rest of the JDK, the class library that we all need, was released, and then you actually had a full set of source code that you could really build something useful from. Now, when we say most of the class library was released, there were some exceptions, and these were things a lot related to graphics technologies, Java 2D and things like that, font rendering, color management, Java sound, the anti-aliasing code. All of that stuff was unfortunately not released by Sun as open source. And the reason wasn't because Sun didn't want to. The reason was because Sun had licensed a lot of that code from third parties. And the conditions of those licenses did not allow Sun to just turn around and release that code as open source to the world. In some cases, some of the people that they licensed the code from didn't even exist. There were companies that went out of business in one case, for example. And so Sun, despite putting out a lot of effort to open source as much as possible and to acquire the rights to release all the code, wasn't able to do that for everything. So there were some gaps in the open source coverage, so to speak, of the JDK at this point. So it actually wasn't until much later in time, about a year later, that the open source community was able to come in and through kind of filling those gaps with their own components and replacement tools, was able to create a truly open source, buildable from scratch OpenJDK. But we'll get to that in just a few more slides. So all this was happening around the 2006, 2007 timeframe. And what Sun originally released was the JDK7 source code. So JDK7 was the first OpenJDK version. And Sun thought that everyone was going to be really thrilled with that, and that would make everyone happy and kind of take away any kind of cloud of closed sourceness that was unfortunately surrounding Java at the time. But if you look at the timeline that all this was happening, the Sun JDK 6 had actually just come out in 2006. So what Sun had done was, they had, as their normal practice, released the closed version, the closed source version of Java, as planned. And then what they released to the public was the next version, the future version of what would eventually become JDK 7. And so what everyone wanted to use in production, and was kind of ready for immediate adoption by the world, JDK 6, was still closed source. And so the community reacted rather negatively to that. They were happy to see Java open sourced, but what they really wanted was they wanted JDK 6 to be open sourced, not just the source code that was this work in progress for some future version of Java that was years off in the horizon. So what happened was eventually Sun bowed to that pressure, and they decided to release an OpenJDK 6. But going back to the drawing board and taking the original closed JDK source code and open sourcing that would have been an amazingly time-consuming and expensive effort that would have been very redundant to the effort that they'd already put in with the JDK 7 source code. So instead of going back to the original JDK 6 source code and open sourcing that as well, what they did is they took the already opened JDK 7 source code and then removed the parts that were added for the change in specification between Java SE6 and Java SE7. And so by removing the new parts, the new API extensions and things like that, basically brought the source code back to a Java 6 compatibility. And so the OpenJDK 6 is actually a branch of OpenJDK 7, if you're just looking at the evolution or the history of it. And so it's kind of confusing for that one brief period in time. But after that, basically, everything kind of merged onto the OpenJDK development process. And after JDK 7, OpenJDK became the reference implementation itself. And so, in a sense, from 7 onwards, the development of the JDK, whether it be open or some proprietary product like Sun's JDK or Oracle's JDK, has all been in more or less the same code base anyway. And so future versions did not have this problem. But there was definitely kind of a lot of confusion about OpenJDK because OpenJDK 6 actually came from OpenJDK 7, which is somewhat confusing and paradoxical. So that's in a nutshell what the OpenJDK project is. Let's really briefly just cover what it isn't to avoid confusion. So OpenJDK is not the ICE-T project. Actually, relatively recently, the ICE-T project has become an OpenJDK subproject now, but that wasn't always the case. The ICE-T project was originally the open source community's response to Sun's open sourcing of the JDK to go in and try and fill in the open source gaps that I had mentioned a few slides earlier. And so, for example, things like the deployment technologies like Java Web Start, which Sun never open sourced, or the browser plugin, or the graphics related stuff like the anti-aliasing rendering software, or the font rendering stuff and things like that. The open source community went and either found pre-existing or wrote new replacements for all those so that they could build the OpenJDK source from scratch without having to depend on any closed source binary components that were provided from anyone else. So they wanted to make an OpenJDK that was true open source. And so the ICT project was partially created for that, but there was also another need. And that was that if OpenJDK was going to be included in, say, like, for example, Linux distributions and things like that as an open source product or component, or project, it needed to be buildable from scratch as open source. And people that are familiar with building the JDK now know that you always need the previous version of the JDK to build the new version. So for example, when we're building JDK 7, we need a working JDK 6 to build and compile the Java portions of the JDK 7 that we're building. So you always need the version right before the one that you're building. But if you're trying to build something completely in open source, that kind of gives you a chicken and the egg problem. And so what the ICT project originally started off doing was modifying a pre-existing project that was part of actually the GNU compiler collection, GCC, to compile Java source code. And so they were able to kind of use that to bootstrap the process and get it so they didn't have to depend on binary deliverables that just kind of came out of the ether from some proprietary code base that they didn't have access to. So that was the ICT project, and today the ICT project still exists, and it's what's responsible for bundling OpenJDK and kind of making deliverables that go into, say, like Red Hat's Linux and things like that. OpenJDK is also not JCP, or the Java Community Process. The Java Community Process actually predates OpenJDK by quite a long amount of time. And the Java Community Process isn't really about an implementation. It's not about making the JDK. It's more about specifying what the standard is. It's groups that get together and decide on different standards and extensions to existing APIs or new APIs and things like that. And so this is a very important thing, but it's different than the OpenJDK process itself. It's also, at least as of today, not Oracle JDK. Oracle JDK is, of course, the JDK that Oracle makes available to the public and its own customers. And you can think of Oracle JDK as basically OpenJDK, but with some magical closed stuff, some mystery stuff added in. And to be specific, that closed stuff includes things like the deployment technologies that I had mentioned a few slides earlier, like the Java plugin and Java Web Start, but also various commercial features like, at least as of today, Java Flight Recorder or app class data sharing, technologies like that are not currently open source yet, but they are included in Oracle's proprietary JDK. Now, of course, as was announced several months ago, there's a plan right now for most, if not all, of that stuff to be open sourced in the very near future, and that is moving on. But as of today, if you go and you download Oracle JDK, it currently has features that are not available in OpenJDK. A year from now, this will probably be a very different situation, but right now, as we're delivering this webcast, there's still a difference between in terms of features between the two different JDKs. So, like I said, the OpenJDK project is actually kind of an umbrella project that has all sorts of sub-projects under it. And those different projects can kind of fall into some really general categories. So like if you want to port OpenJDK to a new platform, you might do that under a new project. So for example, when we were going to port OpenJDK to what at the time was known as OS 10, or now known as Mac OS, there was a BSD port project that was started to track and manage that porting effort. There's also projects for individual features. So for example, there was a Jigsaw project to manage the work on Jigsaw. Each major new JDK release, historically anyway, has had its own project. So there was a JDK 8 project and a JDK 9 project. that handled the mainline development of those major feature releases of the platform. And there's also update projects that handle the post-release of each major version. So, for example, 8 update, 1.4.1 or whatever. If we're going to release something like that, the open source contributions to those update releases are managed through an update project. So we'll actually see, just to see what is all available, and I really meant to click on Firefox there, but if you go to, sorry about that, keep opening Firefox out of habit, and Chrome just ran away from me. So I'll try and navigate via kind of the main OpenJDK page, just so everyone knows how easy it is to find everything. But basically, if you just go to Google and you search OpenJDK, one of the first 2 links that will pop up will be the openjdk.java.net. And so you'll see here on the left-hand side, there's a kind of an access bar, or whatever you want to call it. And down through the middle of that, you have a list of all the different projects. And so these are the individual projects that make up OpenJDK. And so you can see how, like, for example, the different major platform releases have their own projects, and then the update releases for the updates that we do after a release ships have their own projects, and things like Lambda or Jigsaw, the major new features, would be developed onto their own projects, and ports to different platforms and things like that would be projects as well. So that was the introduction of the OpenJDK, but for those of you that are still awake after all of that, now is where we get into the fun stuff, or the really important stuff. Here's where we actually talk about the tools and how you can actually get your hands on the source code and start playing with stuff. So hopefully some, or maybe even all of you, were able to get Mercurial up and running. And again, it's just a command line tool. So if you've used Git, you're going to be very, very comfortable and familiar with Mercurial. So the Mercurial command line tool is known as HG, which is the chemical symbol for mercury. And it really is amazingly similar to Git. So I'm not going to go through and give a full crash course on how to use the tool in any level of detail, because you're much better off just kind of going, reading the documentation that's available, and I'll point you to what the best documentation available is. But just as a really brief introduction, so Mercurial is a free distributed source control management tool, and I shamelessly ripped this from the official Mercurial homepage. So I figure that that's going to be pretty accurate. And if this sounds really familiar to you, it probably should, because that's exactly the same thing that Git is. And so it's got kind of a strange name to it, Mercurial. Like, what does that mean? Especially if you're not native English speaker, you might not have heard that term too much. So if we go to Google and try and look up a definition of it, the first one that pops up is, and this is probably very difficult for some people to read, but a person subject to sudden or unpredictable changes of mood or mind. So, like, kind of crazy. I guess the etymology of that word is that people that were exposed to mercury through their careers or whatever would very often develop brain damage of some kind and be kind of crazy or nuts. And so people that were kind of really strange or have sudden mood swings and stuff would be known as mercurial. That's kind of a really strange name to give to your software product. But apparently that's not what they were hoping for in the meaning. The reason that the creators of Mercurial named it that was because they wanted to give an image of flask, of being fluid, flexible, like mercury. So they wanted this is kind of the image that they wanted people to have when they thought of the source control management. So good news, bad news situation. The bad news is it's not JIT. Everyone wishes it was. It's not. But the good news is it really doesn't matter. If you can use JIT, you can use Mercurial. Most people I know kind of just have like a cheat sheet next to their desk. There's a whole bunch if you Google like JIT Mercurial cheat sheets. There's a ton out there, and it's something of an oversimplification. But you can think of Mercurial as kind of just like Git with slightly different commands. So as long as you're just looking at a reference, you can get around a Mercurial. They're both distributed revision control systems, and that's really the most important thing to understand. If you understand what that really means, in terms of JIT, that when you clone a repository, you're not just getting the source code, you're actually getting a full and complete copy of the history of that project. So you actually have the entire repository, including the entire change history of all the source code, in addition to the source code when you clone something. You're basically copying the repository itself when you clone. And so if you understand that, then you really know all you need to know to really use these tools effectively, at least for making, for checking out releases and getting access to the source code. So these are kind of my picks for like the big or top 10 commands that you would use with HG. I'm not going to bore you guys to death by going through each one of them, but as you can see, it's really straightforward, and most of these are going to look fairly similar to JIT commands that you're already familiar with, specifically clone and commit, push pull. I mean, the diffs, these all work exactly the same as they do in JIT, more or less. JIT has a slightly more complicated model in terms of identifying a subset of changes in your local repository that you're going to push up to a parent repository. So it's kind of like there's a staging set in JIT, or a concept of you have several differences between the upstream repository and your local repository, and you're only going to mark a subset of those for inclusion in a particular or a subset of change sets for inclusion in something you're going to push up. And Mercurial is a little bit simpler than that. If JIT has a 3-stage model, I would say Mercurial has only a 2-stage model. So it's a little bit simpler than JIT in that sense. But besides that, it's really pretty similar. One thing that you do need to be aware of when you're working with when you're working with Mercurial is, like JIT, we use hash codes to identify change sets, but we actually use these things called revision IDs, which are a little bit more complicated. Not that much more complicated, but they have 2 parts to them, unlike JIT IDs. And the 2 parts basically break down into a global and a local part. And all you really need to know is that the global one is the one that's important. The global one is going to be the one that's in hex, and it's the long one, and it's the real, kind of the full hash value of that change set. And just like it is with JIT, it's unique among all the different incarnations and forks or whatever of a particular project. And so if you have a global ID, you don't have to worry about that overlapping with a different change set in someone else's copy of the repository, or even in a completely different project, right? So collision is just not something that we really are concerned about. But what's different than that is the local one. And the local one is, as the name implies, really just applicable to your local system. And that is not a hash at all. It has no relationship whatsoever to the hash code. What the local number is just it's a sequentially issued number for every change set on your local repository. So every time you add a change set, it gets incremented by 1. And so it can be an easy way to identify a particular change set, because if you just specify the number, it's shorter, it's easier to type, maybe easier to work with as a human, but there's no consistency between your local repository and anyone else's. And so if you're talking about or trying to use this to specify a change set, and you're talking to someone who's looking at a different repository, this very likely might not be the same change. So in general, we frown upon using these. This is more of just kind of like a keyboard shortcut almost, or that you would use on your own system to kind of save you a little bit of typing. But when you're communicating with anyone else, you want to be referring to the global ID. So another thing to know about is that while both Mercurial and JIT support different project management strategies of either pushing or pulling. So some projects have you push your changes into the upstream repository, and then other ones have you make your own repository somehow publicly available, and then you send a pull request and invite the project maintainer or whatever to pull your changes into the upstream repository. It seems that most people, especially Git users, tend to use a pull request model, but you should know that OpenJDK does not use pull request. We use a push model, so only a certain subset of users are privileged or allowed to make pushes to certain repositories, and we'll cover who those what those roles are and how you can acquire those roles in a future slide. But basically, you have to push your own changes up. You don't send a pull request to have someone else pull your changes from your own. So the opposite of that, though, is when you want to kind of sync up your own local repository with stuff that was pushed into the upstream repository by other participants. That's just a regular pull, and that's going to be familiar to anybody that's used source code control management. So other changes to sync up, you pull down. Your own changes, you push back up. And if you can remember that, you're good to go. So let's look at what the actual source code looks like, and we'll start off here. Remember, I said that we want to look. I want to keep going back to the OpenJDK project page just to kind of show you how easy it is to navigate, and so it doesn't feel like we're just randomly jumping around to different pages. So if we go back here, you'll see that above it's the same side panel where we saw the different projects. There's a section marked source code. And yes, you can download bundles if you absolutely have to, but really what we want to do is we want to be able to clone the repository so we get everything. So if you click on the link that says Mercurial, and then you'll get a list of the Mercurial repositories for all the different projects. So this is arranged by projects here, but each of these actually represents one or more separate Mercurial repositories that are tied to each individual project. And we're going to go ahead and look at the 8U project because it's currently the most recent LTS or long-term support version of OpenJDK. So it still seems to be the one that most people are focused on at the moment, that's actually being used in production. So you'll see here, I clicked on the JDK8 updates project, and you'll see there's a whole bunch of sub projects here. I'm sorry, not sub projects, but there's a whole bunch of repositories here that are associated with the 8 updates project. And these sub repositories, and every project that has multiple repositories has some sort of rule or workflow that determines which one you should use for a particular purpose. And I'm not going to go into too much details now, but it just so happens that for the 8U development one, or for the 8U updates project, the one that you really want to use for cloning and for eventually pushing your own fixes for is known as 8U dev. So this is like the kind of the development one. But you'll notice here that there's actually a whole bunch of kind of what look like subdirectories or something under here. And what these are is these are actually smaller source code repositories. So we have the concept in OpenJDK of a forest. And we'll get to this in the slides in just a bit. But a forest is basically a collection of source code trees. And so instead of having the entire JDK as a single repository that you have to clone as one gigantic monolithic download or transaction, you can do these individually. So if you're working on just the JVM, you could be updating or pushing changes and managing the history just as it pertains to the JVM, and kind of ignore the other components except when you're trying to do a JDK build. So we'll look at what that looks like in practice in just a little bit. But so you'll see here we have these these individual repositories. So the actual the JDK 8U dev or actually any of these other what we refer to as root repositories are almost empty. They don't have any files or anything. They're really just kind of a placeholder for these other source code trees to be under. And the ones that are kind of most important usually are the hotspot one, and then the JDK one actually holds all of these class libraries. So that's where most of the actual what we think of as the Java platform is really made up between JDK and hotspot. But anyway, so if we want to actually look at some source code here, let's just go into the hotspot one here. You'll notice that this is the change history here. And if we look at an individual change that we can pull up, we get a diff. And you'll notice that the change set, like I said, it's ID'd by two different parts. So the part over here, this is the global portion. And then the part on the left here is the local ID. And like I said, for this local ID number, just ignore that. You don't want to really use that. What you're interested in most cases is the hash code here that uniquely identifies this particular change set. So you can look at individual changes that have been checked in. None of this should seem too strange to anybody who's worked with JIT before. But there's also an option over here called Browse. And this will actually let you look at the source code directly. And so this gives you a very kind of bare bones source code browsing experience. So you can go and pull up into individual files. There's no search functionality. There's a search bar up here, but actually it only really searches for change sets, not source code files themselves that are checked into the repository. So this is mostly good for if you really need to look at what does this version of the JDK, what exactly does this file contain or something, if you need to kind of confirm, what's currently checked into the repository today. You can go through this interface and get access to a particular file without too much difficulty, and so you don't have to have Mercurial installed on your local machine or clone anything out, or you can kind of just instantly go on the web and check the source code. But like I said, there's no real search functionality here. There's no automatic hyperlinking of identifiers or anything like that. So if you're used to like Lexer or OpenGrok or something like that, a real online source code browser, this is going to leave you fairly unsatisfied. So really, if you want to study or do any kind of debugging of the Java source code, this is not really the tool you want to be using. What you want is to download the source code or clone out the repository to your local system, and then just use your favorite tools, usually built into your ID or whatever, to search and explore the source code on your own. So let's go back to the slides. I don't know why it's not. So I briefly mentioned earlier the concept of a forest. And again, so a forest is just a collection of trees. So one forest is basically everything that you need to build a working JDK. And each individual tree represents one smaller kind of component of that JDK, like the hotspot JVM or the Java SE class libraries, for example. So you'll see here, this is, again, the 8U developments project, and you can see the individual trees that make up the forest here. So what you want to do is when you are trying to get the source code to work on, usually you want to check out an entire forest because you really can't build the individual trees in isolation. You really have to have the entire JDK there. So the standard process is pretty simple, and I'd like to show that to you, but I'm quite frankly afraid to do any kind of serious network activity while we're kind of doing the webcast. So I've got kind of an already downloaded version, but I do want to show you the exact command line that you would use. So it's a two-step process to get a full forest. The first one is you're going to use Mercurial to clone out the root of the forest. That's the upper level source code repository. And so you clone out the root, and then when you clone that out, you'll get just a handful of files, like probably ones that you could count on both hands. It's just a couple files, and it happens instantaneously because it's such a small amount of data. And then once you clone out the root, there's a script in there called get source. There's a shell script called get source.sh, and you run that, and then that will launch Mercurial in the background, and will automatically go out and in parallel sync out all the other repositories or all the other trees. So if you were doing this at the command line, and again, I'm not actually going to do it here live, but sorry. So if I was doing a new clone here, I would just do hg clone, and then I would go to the OpenJDK web page, and I would select the actual root of the project, or the project repository I was trying to clone. So in this case, like say I wanted to contribute a fix to JDK 8 updates project, I would do this JDK 8 udev, and I would take that link, and then in here to my clone command, I would pop it right in there. So just running hg clone, and then the URL for the root of whatever repository I was trying to clone, and I can run that, and that will give me this directory here, this JDK8u-dev, or what, obviously that name will change depending on what repository you cloned. And then when you go in there, now I've already synced this one out, so you'll see a full JDK source here. But before you actually go and run the script to download everything else, this directory will be almost empty. It'll have like a couple README files in it, but it'll also have this shell script here, this get source sh. So all I have to do from here is just run that, through the interpreter and the bash interpreter, and that will go and automatically pull in all of the child repositories. So basically the rest of the forest for you automatically. And it's a lot of code. Depending on the JDK version, it can be like a gig of code easily, maybe significantly more depending on the particular project. And so depending on your location and your internet connection, it can take a while, sometimes 20, even 30 minutes, depending on what country you're in and what facilities you have access to. But you run that, and then eventually you have what you're looking at here, which is the forest in front of you. And we can go ahead and do a build right here. But I do want to introduce a few more concepts first before we start building stuff. So when we talk about building, one thing I should point out, in case there's anybody on the call that's interested in 6 and 7, is there's a huge divide in the building experience between different versions. And it basically comes down to 6 and 7 are kind of horrible to build. A lot of stuff just didn't work really well back then. And so setting up a 6 and 7 build environment involves a whole lot of kind of preparation that is not automated. There's a whole lot of just manual work you have to do, and the process isn't really documented that well. And so, certainly lots of people have done it, and especially for Linux is always kind of the easiest platform to get up and running with OpenJDK. But even on Linux, it can take you a significant amount of time to get all the different requirements ready and installed and everything working. Whereas in 8 and every version after 8, is very automated and everything just kind of works. And so if you're used to the standard POSIX experience of, everything just, you download it, you unzip the tarball or whatever, you run configure, auto config comes in and sets everything up for you, and then you run make and it builds. That's the experience you get with JDK 8 and later. It just all works. And even under Windows. Now, under Windows, there are some additional requirements because you need Visual Studio, and Visual Studio, you can build it with the free version, like Visual Studio Express, but you still have to go out and get that yourself. It's not automated. There's no way we can automate you going out and getting commercial software. But besides installing some prerequisites, we still use automake scripts even on Windows. Everything's done with a Cygwin. So it's even when you're on Windows, it's kind of the standard Unix build and install experience. So it's really straightforward. You just run configure, and configure will go through, and most likely if it's your first time running it, it'll find stuff that you need to have installed that isn't installed. Now, it won't actually automatically go and get that stuff for you, but it does the next best thing, which is it actually tells you exactly what to type in if you're on a supported platform. So, for example, let me just show you example slide here. Hopefully people can read this, even though the print's probably a little bit small. But on this slide, we actually see an example of an attempt to run configure when there were missing requirements on this particular system. So what it's saying here is that the X11 or the X window development headers were not installed on this one, and it actually tells you just type sudo apt-get install and then the names of the packages, and so you can literally just take this and cut and paste it to your command line. And then after apt-get is finished running, then just run configure again, and it'll pick right up where it left off. So usually the first time you do a build on a fresh Linux install, you have to go through this process several times where continuously configure will identify something that is missing, but it tells you exactly what you need to do to get it. You follow along with whatever it told you to do. And after 5 or 6 times of doing that, the configure script will run. And once the configure script runs to completion, then you're pretty much have it made, because we've put a lot of effort into making the configure script really find any kind of problems before they happen. So as long as the source code itself is it doesn't have any build bugs or problems in it, you're probably going to have a successful build if you can get through the configure script. The configure script is really all you need to have the system set up properly, because it will tell you everything that you're missing and give you exact instructions that you can copy and paste into the command line to get everything set up. And it's not this isn't just for the Debian stuff. If you're on a RPM based system, it'll tell you to use yum, and it'll give you the exact yum commands as well. So on Linux, there's a lot of hand holding, and it's very, very kind to you. So when you're running this configure script, there's a few interesting options. There's actually a whole bunch of options, and obviously there's online help that will kind of show you all of them. But the ones that are probably most important are these last two here. This bootstrap, the with boot JDK. This is where you specify the previous already working JDK that you need to compile the Java files in the JDK that you're building. So for example, even the Java-C compiler is written in Java. And so you can't, it can't compile itself. So you need a working JDK in order to build. You need a working JDK 7 to build JDK 8. You need a working JDK 8 to build JDK 9. And so if a suitable JDK is actually in your execution path just by coincidence, then you don't need to specify anything. But in many cases, that's not the case. And so you have to explicitly tell the configure script the location of the JDK to use to build your JVM, or to build your OpenJDK build that you're about to attempt. The other one is, I'm sorry, I misspoke. It wasn't the last two. The other really important one is this enable debug one. And just by adding this option in, you'll end up with what we call a fast debug build. And we call them fast debug builds because there actually is a different, there was an original debug that ran horrifically slowly, and because they had so many different assertions enabled that they were basically unusable. And so at some point, someone at Sun decided that they would make debug builds that were still useful for debugging and troubleshooting purposes. They still had a lot of assertions enabled, but they didn't have so much instrumentation and everything enabled that they ran, they were slowed to a crawl like the old debug builds. So those are known as fast debug builds. And so normally when we say use a debug build, we're talking about a fast debug build. And so very often you'll see, like when you're online, discussions of debug build only options. There's a whole bunch of them. In fact, if we look at the source code for the JDK, there's a whole list of command line options that you can pull up fairly easily. And the number of debug build options is kind of jaw-dropping. So there's all sorts of kind of crazy stuff out there, but these options are not even they're not included at all in the production builds. So if you just go and download like normal Oracle JDK from somewhere, you can't use these options. So if you want to use a debug build option, you have to get yourself a debug build, and Oracle doesn't make those available to the public. So if you want to get a debug build yourself, you have to build it yourself. And luckily, that's extremely easy to do. All you have to do is sync out the OpenJDK source code and add this flag to your, when you run the configure script. And then when you do the subsequent build, you'll end up with a debug build. And that will have all the debug options enabled, in addition to a whole bunch of troubleshooting stuff, internal troubleshooting assertions. So, for example, if you're experiencing crashes of some sort, the assertions that are enabled in a debug build would hopefully allow us to identify some sort of inconsistency or whatever earlier to better pinpoint where the actual memory corruption or whatever that's causing the crash happens. But yeah, so this is kind of the main reason. This is one of those OpenJDK power user type use cases where just having access to the source code allows you to do this kind of troubleshooting, make your own debug builds. So let's actually do something here. I've done enough talking, so let's actually show you what this looks like in practice. So what I'd like to do as a demo here is, before we change anything, we can just run the, just run Java and then -version here to get the standard version string. And that will crank out, a not entirely unexpected, version string that we've all seen a million times and are all familiar with. But why don't I add something to the JVM's startup code that will actually print something out every time the JVM fires up. So in this case, when I presented this material at Java 1, what I did was I added this phrase, hello Java 1 2017. So obviously this is completely useless, but it's just kind of a proof of concept. But the idea here is that I want to show how amazingly easy it is to kind of get into the guts of the JVM and add something. And so if you're asking yourself, well, does this code actually get called ever? Like I'm looking at some source code here, but I want to know, add a printf to that, and you can get code. You can get your code, built into your own custom JVM, and you can run that. And again, I keep referring to the JVM just because that's my area of skill or whatever experience, but this applies to the entire JDK. So, you could be editing Java source code that's part of the class libraries, or native code that's part of Java FX, or, the Corba implementation, or anything. It's all there for you to modify and use as you see fit. But in this one, we're gonna kind of have our goals be relatively humble, and we're going to settle for kind of a hello world type example. So let's actually try and do that. So again, here I am with this is a fresh clone that hasn't had any changes made to it. And I'm going to go into the hotspot directory here. So this is the source code for all of Hotspot, and it's always fun to type stuff when you have an audience. So obviously I know off the top of my head where the code that I want to modify is located there. So you know, it's not like I was able to just pull this out of thin air. I know this because I know where the startup code for you know, thread initialization and things like that are located within the JVM. But the point here is that if you were looking in like a source code browser, or you were grepping through the source code yourself and you found something of interest, you would be able to modify it in a similar way here. So I'm going to go in and I'm going to just open this file up. And okay, and this right here is kind of the end of the kind of the JVM, the thread system initialization code here. So this is always called when the JVM starts up. And the very last thing we do is kind of, you know, assuming that no error has happened, we return a JNI OK. One tip is when you're looking at JVM code, if you understand the JVM or the JNI spec, a lot of the code will look fairly familiar to you, because JNI is used extensively within the JDK and the JVM itself, in addition to external third-party native libraries. So I could go in here and I could say nice and have a cartridge return there. So all right, so I've added my quote unquote debug code. I think that I don't need to include any header files in here. So I've done that, and now I'm going back to the root, the root repository, or the root of the forest. So just to show you, so I was, you know, I just did my modification in Hotspot, but when you run your configure script and you actually run make to build the JDK, you have to be in the root directory of everything here. So the first step is here, I want to run configure. Sorry. And I've obviously built on this image before, so all the required packages are installed on this one. But really, that, like I explained before, that's a very simple task. So you know, once you have everything installed, you know, you're kind of good to go. So my configure script is run, and I'm all set. And it kind of gives me some statistics about you know, how many cores it's going to try and use, and you know, where it found a working JDK to try and do the build. Technically, because I'm building JDK 8 here, I really should be using JDK 7 to compile the Java files, but this will actually work even if I'm building the same version that I'm using as my boot JDK. So I ran configure, and then I just run make. And it's off and it's running. And the build infrastructure is actually amazingly good at kind of parallelizing things. And so if you have, you know, some ridiculous machine with, you know, like one of those new Threadripper CPUs from AMD with, you know, 16 cores or whatever, it'll identify your resources and it will try and run a whole bunch of different compile tasks in parallel to kind of squeeze as much performance out of your machine as possible. So this setup is extremely good at kind of using all of the resources you have hardware-wise to actually get something built. So this will take a little while to run, especially because it's on such an underpowered VM instance right now. So while that's going, we'll go back to the slide deck, and hopefully this will be done when we're finished. So obviously the hello world example is pretty trivial, but in real life, if you're actually adding something or making a change to the JDK, you will most likely be expected to include a test case of some kind. and this almost always applies. So the only exception is usually like a doc change of some kind. But usually if you're making any kind of code change, some sort of test case is almost always necessary. So if it's a bug fix, you need a regression test to kind of prove that the test or that the bug is actually fixed. And if it's a new feature of some kind, then you need some sort of functionality test or unit test to prove that the feature works. And there's obviously a whole bunch of different frameworks out there for writing tests in Java or for Java, but we actually use our own framework, which is known as JTrag. Now, JTrag is, it's part of OpenJDK. It's completely documented. It's out there. The source code for JTrag is out there. It in and of itself it's its own project under the OpenJDK banner, and all of its source code is available. And so I would point you, once you get to that step, is you have to go and basically read the JTrag documentation. And it's actually pretty easy to use. It's basically a standalone tool that will run tests that conform to certain standards that are laid out in its documentation. And so as long as you construct your test case in a certain way, the JTrag tool can identify it and run it automatically. And that's not mutually exclusive with just having a regular test case that has a main method in it that you can just call from the command line standalone. So you can write test cases that you can run standalone without JTrag, but are also executable by JTrag at the same time. And so for most code reviews, they will expect to see a JTrag test included with your change set. So it's not just what you're changing or adding, but how you're testing that. And sometimes, if you're lucky, you don't actually have to make a new test from scratch. You can just kind of add additional test cases to a pre-existing JTrag test that's in there. So before you ever make a new JTrag test, go looking to see if there's something that already tests the functionality that's related to whatever it is you added or fixed, because you might not have to actually make a new test from scratch. So that's kind of the technical stuff. Now we will go back and return to our little demo to see how our build went after we go through these process and roll slides. But for now, we're going to transition to the final portion of our talk, where we're going to go over some of the more kind of boring stuff, but important, which is how the actual project is run and how you can participate in it, and what you have to do to kind of become a contributing member. So first off, if you want to participate, you should decide what exactly you're going to contribute. Now, obviously, new features are exciting, and everyone wants to do something like that, but it's also a much more complicated process because, as I already mentioned, there's something called the Java community process, which is what helps define the specifications themselves. And so you can't just add a new feature that doesn't have a specification that it is adhering to. You basically have to get the entire community to agree that new feature needs to be part of the JDK, especially if you're doing anything that impacts an API, like adding a new method or something like that. The specification has to be modified or changed, and that's only something that can be done in a future feature release of the platform. So adding a new feature is exciting, and hopefully everyone will get a chance to do that at some point, but it's not something that, it's not going to be your first step in the project. Realistically speaking, the first thing that most people do is they find a bug and they fix it. So that's what we're going to cover here, is focusing on fixing something. So if you want to find a bug, well, obviously you want to look at the bug tracking system, right? And there's actually two systems that are out there. There's bugs.java.com, and then there's the JDK bug system. And I'm going to pull up each of those. I think pretty much most people on this call has probably seen one or the other. We'll look at bugs.java.com first, because I think this is the one that most people have seen. Now, cosmetically, this has changed a bunch of times. especially with Oracle's acquisition of Sun, the CSS templates and whatnot have changed rather extensively to kind of Oracleize this interface. But the underlying system itself, or the underlying interface itself, is pretty much the same as it's always been. And then it gives you just kind of like, so there's some basic fields associated with every bug, and then more or less a description. But to be honest, a lot of the bugs here don't really have all of the information that you'd really want to kind of see, and it's not necessarily organized in a way that is conducive to finding what you're looking for. And the search also is not particularly great. It's got its own search engine that's not very effective, and sometimes for reasons that are beyond my comprehension, it's unable to find stuff, even though there's match keywords in the bug description and stuff. So this is the most well-known bug database, but it's also probably the least useful. So this is, if you just Google a particular bug, usually this is the first hit that will come up, but I would encourage you to not use this particular interface. So what should you be using? Well, that's the other one. That's what's known as the JDK bug system. So JBS, I'm just doing a shortcut by going through the Oracle domain, but there's actually bugs.openjdk.java.net. So this is kind of what I would call the real bug system. This is the bug system that we use and that the OpenJDK community uses. So if you're looking for a bug to fix, this is where you should be searching. Or if you know of a bug and you need to get people's attention or whatever, eventually, hopefully that bug report will end up in this particular system, because this is where this is what we actually use to work on the JDK. So we have these two systems, but they're actually not two different systems. They're really two interfaces to the same underlying set of data. And so there really is actually no distinguishing between them. They're really just two different views of the same underlying infrastructure. So like I said, there's the bugs.java.com that used to be, Sun had the exact same interface, just with different cosmetics or different branding. And this has been around forever, but it's really not that good of interface. It's known mostly for its simplicity. So non-technical users might be looking at it or trying to look up a bug or identify some problem that they've come across. But it's not really meant for people who are, kind of advanced or kind of like, well, I would say really even just Java developers. It's simplified even beyond that audience, and it's really just aiming for even non-technical users. So that's kind of the downside to it. But the good side is that anyone can file a bug report. So, for example, we get several hundred bug reports a year through this system, where kids are just coming in and saying that Minecraft crashed. And so when Minecraft or when the JVM crashes, there's the HS error log, and the HS error log actually directs people to go to this interface and submit a bug report. And it's great that people do that because it lets us know if there's some sort of regression or problem in the latest JDK update. This is kind of the carry in the coal mine that will help us identify that there's some sort of major problem out there. And so in that sense, it's really good. But like I said, the interface itself, as far as viewing data, is really not and searching for data is not really as good as it could be. The other interface is the JDK bug system. And this is what we use. And if you've used Jira before, this is going to look very familiar. In fact, not only are we using Jira, but we're gone to great lengths to kind of not avoid the temptation. Or we've gone to great lengths to avoid the temptation of customizing it. So as much as possible, we've preferred configuration over customization. And so it should look and feel very familiar if you're used to using Jira, which is pretty much everybody on Earth these days. So the JVS bug system is interesting because it actually kind of has this schizophrenic existence where it serves two different masters. One is, of course, the OpenJDK community. Hopefully that will include all of you. Everybody, both inside and outside of Oracle, that's working on the OpenJDK project to further the Java platform. But it's also used internally by Oracle Corporation for stuff that we don't necessarily want to or are able to make public. And again, the textbook example of that would be security vulnerabilities. So security vulnerability information, Oracle is extremely protective of, and we want to make sure that none of that information is leaked or made public or is visible in any way to anybody outside of the company until we do a CP release. Now, there are actually some small exceptions for the OpenJDK community for specific partners like Red Hat and SAP that are working with us where we discuss security issues. But generally speaking, that's stuff we want to keep internal to the company. There's also cases where sometimes information comes up and it involves a particular customer of ours, and obviously that we don't want any of that data that is about a customer situation or issue to be leaked to the public. And so there's data that we just cannot make public in that same bug system. So you have the kind of this classic Venn diagram where both communities are using it, and there is this very nice overlap, but there's also sometimes some strangeness in that there's things that you might see in JVS that don't make sense to you because perhaps some description or update was actually intended to be read only by internal Oracle people, but the person that did that update forgot to mark that update as being confidential or something like that. Like I said, so it's Jira based. We tried to keep it as quote unquote standard as possible, but at the same time, there's two important differences that you should be aware of if you're using it and you're coming from a different Jira system or you've got experience with Jira before. One is that the way we track backports is different than most projects in how we use the Jira system. So what we needed to be able to identify not just backported versions, but builds within individual backports. And without actually customizing the system, there was no easy way to do this. And so what we ended up doing was we ended up using separate bug IDs or new bug IDs for each individual backport that we do. So what you're looking at here in the slide, and this is a great example of information that just isn't available in any kind of easy to understand way from the other interface, the end user oriented interface at bugs.java.com. You can see here that this particular bug was back. The fix for this was originally done by Stuart Marks, and I'll just go to the previous slide again. Actually, so Stuart did this fix, and he fixed it in 9, and it went into build 39 of JDK 9, meaning that was a pre-release version, right? So this was in development of 9, but then it was backported to 9 embedded, which is a kind of a separate product. And then I went and I backported it to JDK 8, and it went into these two different builds of JDK 8. So by looking down here at this backport section, you can see which previous versions of the JDK a particular fix has been backported to. And this kind of using the separate bug IDs to identify backports, as far as I know, is fairly unique to us in terms of how we use the Jira system to track that information. The other big change is that we've added some custom functionality to the search stuff. So you can actually use regular expressions to specify labels and versions. So versions are just like different versions of Java. So you can specify that for a particular search you're only interested in hits, that are come up with, between versions 5 and 8 or something like that. But there's also labels, which are just basically tags that we associate with individual bugs. And you can search those labels with regular expressions as well. And so you could look for some labels tag certain bugs as being, eligible for backports or something that the original developer thought we might want to consider backporting to a particular release, but didn't have the resources or bandwidth to do that his or herself at that moment in time. And so they might put a label on a bug to tag it as something that someone else should consider for backport later. So we use tags for all sorts of different reasons, but you can search them using regular expressions to kind of narrow down the scope of whatever you're looking for. So both really useful things when you're using the search and the search tool. And again, the rest of it is just kind of standard Jira. So if you're used to using Jira, you're going to feel right at home and you're going to be able to find what you're looking for very quickly. So we said anybody can go to bugs.java.com and can file bug reports and look at all the data. So what about the Jira instance? What about JBS, the JDK bug system? Well, the good news is everyone can access that as well. So you don't need any kind of login or anything. You can go right there and you can start searching for bugs. So even if you have no intention of even ever downloading the source code, just the ability to go in there and look at the quote unquote real bug database that we use. You can find information that might help you in troubleshooting some sort of issue if you suspect that issue might be being caused by a JDK issue. But saying everyone has access is not the same as saying everyone has the same access. And unfortunately, the access that everybody gets by default is read-only. And so obviously there's roles that you can attain later that would give you write access, but by default, especially if you are completely new to the OpenJDK project and you don't even have an ID, for example, all you can only do is see what's already there. And again, some bugs are not even available even if you have an OpenJDK ID. There's some bug reports, and even there's some updates within individual bug reports that are otherwise public that are confidential to Oracle, and we don't disclose to anybody. But I will say that those bug reports, we put an amazing amount of effort to only hide bug reports that need to be hidden, meaning they have end user data that we can't make public, or they are discussing a security vulnerability or something like that. We don't arbitrarily just make bugs, mark bugs confidential without good reason to do so. So as far as seeing what you want to see and finding what you want to find, you should be able to do that today. If you want to submit a bug report or make changes to a pre-existing one, that's a different situation. So let's think about the case where there's some issue that you found and you want to document or let people know about, and you want to file a bug report. So what are your options? Well, you really only have two if you're new to the OpenJDK community. One is that you can go to the bugs.java.com, the kind of end user oriented portal, and you can file a bug report there. And that's probably the easiest one, and one that I would recommend in general that you use, because even though the interface isn't really great for searching and looking at bugs, for entering bug information, it's completely suitable. So that's certainly one option. Another option is to just go onto an appropriate OpenJDK alias, a mailing list, and discuss the issue and ask somebody to file a bug in JBS on your behalf. And on your behalf just meaning that the bug wouldn't necessarily be tied to you in any way, but that they would do that for you, so that you would get your information in there and you'd be able to see it. But really, I would recommend just going to bugs.java.com and filing a bug report there. So what happens? You file your bug report there, and you expect it to show up in both, through both interfaces immediately, and you can't see it at all. So what's up with that? So the truth is, it's all one system in the background, but we segment segregate the bugs when they're new. And so new bugs that go in through the web interface, the the bugs.java.com interface, are what we refer to as Java incidents. And the Java incidents, the only difference between them and quote unquote normal bugs is that they haven't been triaged in any sense. And we do that because otherwise 4chan would go in and file a whole bunch of, interesting bug reports that we would not want to have, public with Oracle's banner all over the place. So it doesn't take a whole lot of imagination to come up with scenarios where, you don't want to have any kind of user interface where people can put something in and it just goes public with whatever whatever random people typed in. So to kind of prevent abuse and things like that, and also, not just malicious abuse, but there's also cases where people are reporting something that they don't understand as a security issue. They just see it as a bug, and so they report it. But when we look at it, we go, "Wow, that's a security issue," and so we don't want to make that public until we also have a fix, because we don't want it to become a 0-day. So we have to triage bugs before we move them over to the main system and make them, kind of world visible and stuff. But that happens pretty quickly, ideally on a scale of a week or two. So the standard process, if you don't have an OpenJDK ID, is to go in and file a bug under Java incidents and then just wait a week or two, and it should eventually get triaged and moved into the real Jira project, which is known as the JDK project. So this is a theme that I've returned to again and again, and I think I'll probably repeat a few more times before this is over. But it's an extremely complicated system. It's an extremely complicated project with a whole lot of different people and moving parts, and so it's not really possible to understand everything or always know what the next step is or what you should do. So don't hesitate to just ask. No one's going to get angry for you for not knowing all of our processes and stuff. And we really are very excited and happy that people want to participate in this. So when people, if you're like, oh, I don't know, where should I submit this bug report? How does this work? Just ask on the list. So that kind of helps us segue into talking about the mailing list. There's actually a whole bunch of them, and they're interested in that they're moderated, but they're basically open. And what I mean by basically open is that unless you're posting something crazy, like conspiracy theories or something, anything you send to the list will eventually get put in. So the rule is that if you're subscribed to a list and then you post to that list, it'll actually go through immediately. So that there's no real moderation if you're a member of the list, and anyone can sign up to be a member of any list, with the exception of say the security stuff. So it's very easy to join a list and to start posting to it immediately. If you're not a member of a list, which just means you haven't chosen to sign up yourself for that particular list, and you send mail to it anyway, it will actually be held until a moderator can come and look at the message and kind of okay it for it to get sent on. In practice, what I recommend is that, because it's very easy to unsubscribe from lists, so if you want to post to a list, it's probably easier just to join that list and then post to it. And then if you feel the need, you can unsubscribe very easily at any time through the automated system. So there's really no harm in subscribing, and that kind of saves you the overhead of having to wait a day or two for a moderator to come in and okay your message to get it out of quarantine. One thing to be aware of when working on the mailing list is that they're archived. So anything you say on the list will be around forever. And it's not just us archiving it. These aliases get kind of syndicated in a sense by third parties out there all over the net. So very often when you're searching about different stuff in OpenJDK, the first couple hits from Google will not be our archives. They'll be other archives that other companies or people put up there with random advertising and who knows what. That they're just trying to drive traffic to their sites by recycling our content basically. And so anything you post, just be mentally prepared that it's not just going to be on the internet forever, but it's going to be all over the internet forever. So what I always tell people is, become famous in a good way. When you post to the mailing list, use spell check. Just don't just be aware that everything you do, like 10, 20 years from now, you'll be job hunting, and this stuff will come up on, when people Google your name. So definitely, make sure that it's always okay to ask questions, and it's really good to ask questions, and no one's ever going to jump down your throat or anything for not knowing the processes and stuff like that. But just be aware that everything you say will kind of be immortalized in the net. And there's also, like I said, everything's archived, and so you can go back and look at those archives very easily. So let's just show a really quick example of that. So again, just to show you everything I'd do, just going to Google, and if I type OpenJDK mail, if I search for that, the first link that pops up under OpenJDK mail is our mailing lists. And there are a whole bunch of mailing lists. We've got, every project has its own list, but even some projects have multiple lists. Hotspot's kind of notorious for having a whole bunch of different projects and repositories and everything. So there's each compiler team has one, and Graal has its own team and stuff. So let's just look at let's look at an active one. So let's go into Hotspot, because that's sorry. That's obviously before, so I scrolled too much again. Sorry, it's hard to. Okay, that's not working. So I'm just gonna go into any. Yeah.
Yeah, Dave, just so you know, we have lots of questions here, so if you want to go ahead and start answering them at some point.
Yeah. So I've probably got about maybe 5 more minutes of the slides here. So do you want to just finish this off, or?
Yeah, go ahead. I just use it.
Okay.
Your interlude. Yeah. Okay.
Yeah. Sorry. So anyway, yeah. So as you can see here, everything gets archived. So it's good. You can kind of point, Google to this using the, when you specify Google search, you can say site : and then, mail.openjdk.java.net, to kind of search through the archives here. But you'll find that, everything is kind of stays here forever. So you can go and search and pull up threads and whatnot. But that's the mailing list. Like I said, when in doubt, reach out on the appropriate list. And it's not always obvious what the appropriate list is, but just pick one that sounds right. Look in the archives, and you can kind of get a feel of what kind of discussions go on that list. So, for example, classic mistake is people that are looking for stuff about the Java-C compiler end up on one of the JIT compiler lists or the Graal list or something like that. And if you take a moment before you post to just kind of look at the archive, you can see what people are talking about on that particular list, and usually it's pretty obvious from that if it's appropriate or not. But it's not the end of the world if you're wrong, and people will point you to the correct list if it's not the right one. So if you can't figure out which list you should be talking to, go ahead and just pick one that sounds right, and we'll steer you in the right direction. So here's, for example, here is the hotspot ones that for some reason I couldn't scroll to. So you can see there's multiple garbage collection ones, there's a runtime one, there's a compiler one, there's an overall hotspot dev one. There's just a lot of lists, and we'll be very friendly, and we'll kind of point you there. Another thing to keep in mind is sometimes responses don't come immediately, especially if we're in the middle of some sort of crunch on our end, and we've got like an upcoming release or something. Sometimes it can take a week or two before we get the bandwidth to review an outside code contribution or something like that. So another thing that I would like to ask is just people to be patient. with the process. And so sometimes if you do send something out to a mailing list and you don't get a response immediately or even in a day or two, just kind of bear with us. It's okay to ping. If you go a week and there's no updates or anything, definitely let us know, because it is possible that it was overlooked or something like that. But understand that being an open source project, sometimes it really does come down to people spending their own time on the weekends to go in and look at outside contributions and things like that. And so it happens when people have the time to do it, and people don't always have the time to do it, unfortunately. But that's the same with any open source project, really. But please bear with us, because what we absolutely don't want is, we don't want people to be like, oh, I didn't get a response, so they're not interested in my contribution. No, like if there's something wrong with the code you submitted, or something like that, people will tell you. So if you don't get a response, it's like we just didn't have the time, or we didn't, we were so busy we missed something and it fell through the cracks. So please don't give up. Please don't be discouraged. Just ping the list again. You can reach out to me, and just try and get someone's attention and follow up on it. So you've got the right list. You found a community, you filed a bug, or you found a pre-existing bug that you want to fix. And then you pull down the source code, or you clone it, and then you fix. And I have the magic hat here that you're going to pull a rabbit out of, because obviously I can't cover what you're going to fix or how you're going to fix it. But let's just say for the sake of today's conversation, you fixed something. So after you fix, you have to do a code review. And the code review is obviously not unique to Oracle JDK, but some of the rules and how we do things are pretty unique to us. So as a rule, anything that we put into OpenJDK has to be reviewed in the open. And what that means is, actually it has to have a code review that's done on one of the mailing lists. So you do the code review on a mailing list. And then once you get the appropriate approvals for that, you or someone on behalf of you will then push that change into a repository. And when you're first starting off and you don't have the permission to push to another repository, you have to have someone push for you. So to do a code review, we use a tool called WebRev, which is another kind of homegrown tool that just kind of makes it easy to look at and reference diffs. So there's a server, CR, which stands for change request.openjdk.java.net, that hosts WebRevs. And so once you have an OpenJDK ID, you'll have a home directory on this server, and you can SFTP or whatever your or SCP your WebRev. A WebRev is just basically like a diff on steroids, and you make the WebRev from your change, and then you upload the WebRev to cr.openjdk.java.net, and then you send out a review request to the appropriate list, asking people to look at the WebRev that you uploaded. So let's look at what that actually is, how that's actually going to look. I can't believe this is still running. Like I said, this machine's a little bit slow, but I'm thinking it's almost done with the build. So the WebRev itself, the tool, is just a shell script. So and you can get it from the OpenJDK site. If you just Google for WebRev, it'll pop up. But it's a shell script. So I'm going to go into the I'm going into the hotspot repository where we made our change, and here I'm using Mercurial to pull up. First, I'm going to say status just to identify what file's been modified. And if you remember, we modified this thread C++ source code. I could, of course, just do like a diff, and that'll this will give me a standard diff. And for a small change, this is fine, but many changes are across a whole bunch of different files, and it can get very confusing to try and look at like just a standard patch to see what has changed. So someone at some point at Sun decided that they would make this WebRev tool, and so we'll run it right here and to see what that looks like. So I think that's our. So here I'm just calling the script, and it handles two types of changes. It can be a change that you've already pushed into your local repository, or I'm sorry, not pushed, but committed to your local repository, or you can look at changes that are not committed at all. And the N option here that I'm using is this tells WebRev that I want it to basically look at the changes that are not currently committed to any particular, so there's no change set that is associated with this in terms of Mercurial yet. It's just it's a diff between what the repository proper has and what my local file system has. So I type webrev -n, and that's it. And it'll automatically go in and look at what it identifies what's changed, and it creates a whole bunch of different, kind of diffs, diff views of it, or whatever, and outputs it. And then after it executes, it creates a webrev zip and a webrev directory. And the webrev zip is really just a zipped up version of the webrev directory. So I'm going to look here because this is my local file system. So I can actually jump right in and go here to hotspot, and then going to the webrev directory, and here's an index.html. So it's basically a web interface to my changes. So it's just a more user-friendly diff in a sense. Instead of, a lot of open source projects just, people are passing around raw patches. But this is just kind of a more user-friendly approach. So you can see here it very clearly identifies, which workspace you cloned and all that other stuff. You can get a raw patch, which is basically the culmination of each individual file diff right here if it's multiple files. So you can get this to just kind of, you can click this and, download it to your local machine, and assuming this is remote, the WebRev is remotely hosted, and then you can apply it to your local repository you have if you want to build and test it out or something like that. But you see here, I can get, different like UDiff and SDiff is a popular one. So, it just gives you different versions of the change, and different people have different preferences about what they like to see. And, so you can very quickly look at the old version of the file before the modification, the new version of the file, all that stuff. And you can have 100 different files in this particular change set, and all of them will be listed here in this way. So this is what people prefer to look at when they're reviewing changes. And so generally speaking, no matter how small or big the change is, you'll be expected to generate a webrev for it, and then to put it onto that cr.openjdk.java.net. And when you upload it, you're not uploading the zip file, you're actually uploading the directory. So usually what we do is we run the webrev tool to generate the webrev directory, and then we name it something, to include the bug ID. So like webrev _ and then the bug ID of whatever bug we're trying. And so, for example, just to look at my own home directory, if I go to cr.openjdk.java.net, and then I can go. So here you can see what I do is I usually just name them after the bug ID. So I can just pick any random one, hopefully nothing too embarrassing. There's the webrev directory. And then so people can see the change of, whatever it is I was working on here. So it's a very easy way to do code reviews. So people just expect that these are the tools you use, and this is the process that you'll follow when you're trying to submit a change. And a lot of people are surprised by that, because if they're used to other open source projects, they're like, well, I just send a diff to the mailing list, but we do things a little bit more complicated, for better or for worse. So anyway, so that's the review process, and then you want to have some critical mass of reviewers basically approve it. And this is where things get a little bit complicated, because different projects or different teams have different rules about how many reviewers is enough. Generally speaking, the rule of thumb is you need at least 2 reviewers for most changes, especially if it's a JVM change. Unless someone specifically says you only need 1 reviewer for this change, you usually want to assume that you need 2 reviewers. But you'll notice here that I'm referring to reviewers, and I'm using a capital R. We kind of have this strange convention where we talk about lowercase r reviewers, which is just anybody who's on the mailing list and looks at a change and approves it, or thinks that it's a good idea. And then there's official reviewers, which are people that actually have the role reviewer and are allowed to review things. And that's a rather kind of a high role to achieve. So lots of times people will say that I'm a reviewer, and you have to pay very close attention to whether they're capitalizing it or not, to tell if this is one of the 2 reviewers that you need to actually get approval. And most changes really do undergo several iterations where people come back, give them feedback, and then that feedback will be incorporated into the change, and then another review iteration takes place based off of those changes. And so during that process, a number of people, only a subset of which are actual official reviewers, might take part. But anybody who has something constructive to say about a change being discussed is of course welcomed to kind of join in the conversation about that. So once you have whatever approvals are necessary for whatever component you're working on to get a change pushed, you need to get that change pushed into the repository. And there's another role that's lower than reviewer, but not granted to all OpenJDK members, known as committer. And a committer is somebody who has permission to push to a particular repository. And even if you are a committer, there's cases where there's certain repositories that you can't push to. And specifically, the most well-known case is the JVM repositories, or the hotspot repositories, because the hotspot is so critical and so easy to break. We actually enforce a rule that any push has to go through our own internal build and test system before it gets pushed, meaning we actually don't push directly into those repositories ourselves. As Oracle employees, what we do is we submit our change to this internal system, which is known as JPRT. I'll talk about that in the slide. And then that system, builds the JDK with the change on a whole bunch of different platforms, and then tests it on all those different platforms. And only if all those tests pass will it push on behalf of us. And so for outsiders, people outside of Oracle, because unfortunately they don't currently have access to this build system, they can't push into the JVM repositories, at least for the mainline dev branches. Now that's a problem that we're aware of. It's kind of a very well-known pain point, and it's something that we're working on to try and resolve. But as of today, it's not resolved yet. So even if you have committer status in OpenJDK for the particular project you're trying to commit to, you still might need to ask for somebody who's an Oracle employee to push it on your behalf. And that's something we're happy to do at any time. So in practice, it's really not a big deal. So I've talked about committers, reviewers, what are all these terms? So there's a number of different roles within the OpenJDK system, and these are granted on a project by project level of granularity, meaning that you might be a contributor for one project, but not a contributor for a different project. It really depends on which particular project you're interested in participating in, that you're going to be concerned about what role you have under that project. So basically, I kind of have these in general, of order that they would be acquired by a particular person. You can kind of think of these as rank, but that's maybe an oversimplification. But basically, there's contributors, who's just basically anybody who has contributed some fix. As soon as you give one fix to a project and if it actually gets taken in and accepted, then you're a contributor. If you have at least 3 fixes to a project, then you're an author. And then it goes on from there. I'll go over the individual roles of specific slides. So to be a contributor, you have to have 1 fix in somewhere, but you also have to have signed the Oracle Contributor Agreement. And that basically is just a, kind of like the iTunes agreement in a sense. People just kind of sign it and mail it in. But the gist of it is that Oracle is, basically owns what you contribute. The reason that we have that is because when you contribute to OpenJDK, Oracle reserves the right to take part of that source code and also use it as, in their own proprietary product, the closed JDK or Oracle JDK. And so they would not legally be allowed to do that if they didn't have your permission, in a sense. So in a way, what you're saying is that yes, you're contributing to OpenJDK, and that's GPL project, and your code is shared and accepted under the terms of the GPL, but Oracle's also allowed to use it as well for its own stuff. And that's necessary because we need to keep OpenJDK and any proprietary implementation in sync. We don't want to have anything branching. So the contributor agreement, it's actually not that scary. I kind of joke about the iTunes agreement, but it's actually pretty short and reasonable and doesn't have a whole lot of crazy lawyerese. So you can actually, it's 1 page, you can read it and sign it, and it's not that big a deal. So you just download it, you print it out, you fill it, scan it, and then you mail it back, and then you've kind of gotten rid of that one blocker. But then, of course, you have to submit some sort of fix. So you get a code review out, and if it's your first time contributing, you want to say when you do the code review request that, hey, I've already signed the contributor agreement. Make it known to everybody that you've already signed it, so that people don't have to ask you. So if you proactively let everybody know, and then if your if your fix is accepted, then eventually it'll get pushed. And because you don't have an OpenJDK ID yet, we'll just use your email address. So we'll add a contributed byline to the commit message with your name and your email address here to identify you as the author of that particular change. And you'll notice this is kind of a somewhat interesting example, because here the contributed byline, this is an Oracle employee here, and I want to point out that we internally followed this exact same process. There's no, like, you're an Oracle employee, so magically you're just automatically allowed to do anything you want. We make our own employees go through all these steps exactly like we make anyone from outside of the company go through. So if you're new to, if you're an Oracle employee and you join the Java organization, you go through all this stuff too, just like everyone else. There's, we don't kind of play favorites in terms of that. So, you do 1 contribution and then you're a committer. But if you do 3 contributions to the same project, then you can get what's called author status. And author status is where you're issued an OpenJDK ID. And that will give you all sorts of great stuff. Like you'll finally have your own home directory on cr.openjdk.java.net. Before that, what you have to do is you generate a web rev, and then you have to send it to somebody like me, and then I will host the web rev on cr.openjdk.java.net for you, and then you send that link out to the alias. So it's really, before you get author status, there's a whole bunch of kind of inconveniences that you have to basically work around the fact that you don't have write access to the bug system, and you can't post your web revs to the server and things like that. Once you get author status, all that becomes a whole lot easier. You have your own ID, you can post your web revs, you can go and file new bugs in JBS, you can add comments and modify pre-existing bugs. And the nice thing is, once you have 3 changes in, it's kind of automatic. Like all you have to do is write to the project lead and request author status, and there's no real voting, or it's not like, oh well, this change doesn't really count because it was too small or anything like that. There's no subjectivity to it. It's just you have three things, so you're entitled to this kind of status. Committer is a different situation. So to become a committer, which again means that you have permission to just push directly into HG repositories. That doesn't mean you don't do code reviews, but it means that you've done enough code contributions to the project that you should understand the process, and so it's expected that you won't accidentally push something that shouldn't be pushed. So that means, for example, that when you're doing a code review how many reviews you need, and you just won't do anything stupid, basically. You've been contributing long enough that we trust you to have the keys and not break anything. And so that comes, generally speaking, with 12 significant change sets contributed. So sometimes people are like, oh, I fixed some Java doc here or something, or here's a small one-liner bug fix or something like that. And very often people won't consider that significant enough to warrant kind of counting towards committer status. But they want to see a real history of contribution from you over some length of time, where you've provided at least 12 significant changes, and also original, meaning that they can't just be backports to that someone else did. They want to see either new features or significant fixes that you came up from scratch. And so once you kind of reach that threshold, you find somebody in the project and you ask them to nominate you. Or sometimes, I've gone to people and I've just nominated them out of the blue because I've thought that they should be a committer in the past, but usually you have to approach somebody and make it clear that you want to become a committer. So somehow you get nominated, and then there's a whole process around that where on the public alias will vote. And so everybody who's already a committer can vote on a new committer, and depending on the result of that vote, you'll become a committer, or you'll be told that you have to wait longer and contribute more before becoming one. And the reviewer process is somewhat similar, except for a reviewer, you're expected to have over 40 original significant changes. And this is very hard to achieve. Generally speaking, you don't become a reviewer unless you're working on the JDK full time, which really means you work for Oracle or one of the other companies that is kind of directly contributing to OpenJDK, like Red Hat or SAP or something like that. It's a very difficult bar to achieve if you're doing this as kind of a side project or a hobby. Well, that said, there are some. There's at least one person I know of that has done that, so not impossible. There's also a group known as OpenJDK members. Now, this is not a role, this is a group, and it's not something you have to worry about at all, but I'm just mentioning it because sometimes people get confused because of the name. Lots of times when people start reading all these rules and everything, the first thing they go to is the OpenJDK members, and they think that that's their goal, is to become an OpenJDK member. And the requirements are very demanding and crazy. And the reason is because an OpenJDK member doesn't mean that you have an OpenJDK ID. It means that you're actually kind of like almost like on the board, so to speak. You're the person that you can vote for new projects. It's kind of the absolute upper rank of the management of the OpenJDK project itself. It's not really so much something that those of us that are just kind of lowly engineers worry about too much. So if you see OpenJDK members somewhere in the documentation or the rules, just think for now, it's not something you need to worry about. It's not something, you can contribute and do anything you want in OpenJDK without becoming a member. OpenJDK member is really, if you want to, kind of be on the architect level as far as decision making for the project. It's probably a little more political than technical. So like I said, sometimes if you're a committer, or even if you're a committer, you can't push, and that's because we have this internal system called JPRT, which was the product JDK product reliability testing. Supposedly, I've heard a few different versions of what the acronym stands for, but basically it's this automated build farm and test environment that's unfortunately, as of today, only accessible to us. And we're looking at options to make some sort of framework accessible to people outside of Oracle. But as of today, we don't have anything that's usable. So there are some repositories that you can't push to directly. But like I said, then when you do the code review, just as part of the code review process, you just say, hey, can I have a sponsor to push this for me? And then one of us will jump in and be happy to push it for you. And then finally, we're just very close to wrapping things up here. So backports, this is something a lot of people are interested in because usually, you don't want to, your immediate goal as an end user very often is not to fix something in what will eventually be JDK 10 or 11, but to fix something in the version you're using today, which might be like JDK 8 or maybe even JDK 7. And so in that case, what you're going to need to do is a backport. We generally don't accept fixes just out of the blue for a released version unless we know that the problem is actually already fixed in future versions as well. Because we want to avoid the case where something's fixed in, say, 8, but if people upgrade to Java 10, there's a regression. We want to avoid that. So we want to make sure that upgrading is safe. So we always fix stuff in the latest version and then backport to the earlier LTS releases, the long-term support releases like 6, 7, and 8. So if you want to do a backport, that's fine, but just be aware that different backports are managed by different people. So as of today, at least if my slide's not out of date, it's about a month old. But 6 is handled by Andrew at Azul.
Your slides disappeared.
My slides what?
Your slide disappeared. Maybe you have to reshare the screen.
Okay. When did it disappear?
Just now.
Okay.
I was just kind of waiting for you to get to a point where I could interrupt.
All right. Just 1 second. I just need to find the. We are so close to done here. I have.
Yeah.
Sorry.
Maybe you have to turn screen share off and on again, or on and off again.
I'm just trying to find the.
It's a button at the top.
Yeah, no, I'm sorry. It's just not displayed at all. Oh, here we go. Okay. Not the whiteboard. All right, very sorry about that.
No problem.
And you guys will be subjected to my messy Windows desktop here. Okay, so can you see it now?
Yeah, we can see now.
Okay. So we are almost done here, but so backports. So different people working for different companies manage them. For right now, Azul and people from Azul and Red Hat are handling 6 and 7 respectively, and for JDK 8, it's all Oracle employees. But there's Sean Coffey and Rob McKenna and myself here are responsible for the JDK 8 updates project. So if you want to get a fix into JDK 8, you have to get approval from one of us. But each update project has kind of its own rules, and so very often you have to go and read the individual project page for that update project to see what those rules are. And again, when in doubt, just ask on list. Sometimes, like with JDK 8, we have a separate approval process. So even if you have a change that's already been code reviewed, the code review alone might not be enough because, for example, we need to make sure that a change that might be disruptive to 8 has appropriate level of due diligence done with it before we accept it. So a code change that is appropriate for going into the latest development release like JDK 10 might not be appropriate for going into something that's been out for been GA for 4 years like JDK 8 is. And so because older releases require have higher standards for stability and things like that, we have a separate approval process. But again, just in doubt, ask on the mailing list. We have a rule, at least for JDK 8, where if it's if it's what we refer to as a non-trivial back report, we need a separate code review. So even though the version that went into say 10 might have gotten approved in a code review, if it doesn't backport cleanly, meaning if you can't automate the patching by just applying the patch as is, then you need to have a separate code review for that. So this definition of non-trivial is sometimes ambiguous, or at least people believe it is, but we have a very strict interpretation of it that's fairly rigorous. And so what we mean in general is like that you use the patch command line tool. So the patch command line tool will automatically fuzz things. So if line numbers don't line up exactly or things like that, it'll automatically be able to adjust and apply the patch anyway. But if there's any manual intervention required to apply a backport, then a new code review has to happen. We also make exceptions for, say, path changes. So, for example, with Jigsaw, the entire source code directory structure or hierarchy changed for the class library. And so, the same file just has a new path name because the directories all changed. And in that case, we don't require a new code review, assuming that's the only difference between the later version of the fix and the version you're backporting to. We also make an exception for the copyright date, meaning we don't expect, if the only reason that particular chunk of a patch doesn't apply is because the copyright date was different between the source of the backport and the target of the backport, then you can manually change that yourself without having to get a new code review. There's actually a script that's included in the JDK 9 source tree or source forest that will unshuffle or kind of unjigsaw path changes. So if you have, like I said, in these cases, the files themselves are the same, but the path names have changed because of the modularization of the JDK. And so there you can automate the conversion. So you can take a patch that was meant to be applied to JDK 9, run it through this unshuffle script, and it will give you a version meant to be applied to JDK 8 and possibly even earlier. So if you can unshuffle the patch with this script and then apply it as is to JDK 8, then all you need is the approval from us. You don't need an additional code review to do the backport. So that brings us to the final slide. I hope all of you are still with me and awake, and we'll jump into questions, but let's go look at our build because that should really be done by now. So I want to stress that this was an extremely underpowered VM instance that we were running. So here we can see that it took about 3/4 of an hour to do the entire build. But generally speaking, when I'm running this on bare metal on a modern machine, it's under 10 minutes to build the entire JDK from scratch. So usually it's not this resource intensive. But let's see what we actually got here. So we did the build process and we get this build directory. And I don't want to go through everything that's in here, but the important thing is that there'll actually be a JDK directory. And if you go to the JDK directory, that will actually be, with some other random stuff in here, a working JDK that you can actually execute in place here. So I can just go to the bin and then do Java and version. And we can see here's the printf message that I included in the startup code. So again, a pretty useless thing, but just a proof of concept here to show you how easy it is to just go in and make a change and build. And so it's very easy to imagine all sorts of interesting scenarios where you can go in and try and instrument both the JVM or the class library to kind of debug things or understand even how your own code is behaving better, and all sorts of stuff. It's just the whole process of make a change, build, and test the change. You should be able to do that now with what we've covered in this session. So this brings us to the conclusion slide before we jump into questions. So the biggest takeaway is that don't be afraid to reach out and ask for help. We're very, very happy to help people, and if you want to contribute, we want to help you contribute. So please don't be discouraged. It's a huge process. It's a huge project. There's hundreds, thousands of people involved, both inside of Oracle and out. And there's also lots of change going on, especially now. There was a lot that was announced right before Java 1 and during Java 1 this year. A lot of stuff that was previously closed source is in the very near future about to be open sourced. Flight recorder, things like that. So it's a very exciting time, but it's also a very confusing time. And so, sometimes we're just as kind of lost as everyone else is about, what's the current process and what are the rules? What are we supposed to be doing? So please be patient with us and understanding. We really are doing our best to try and make the process as easy to understand and as efficient as possible. And we're always working to try and improve things and to make it even better. So please don't get discouraged if you find, there does feel like there's a lot of more bureaucracy perhaps than other open source projects you might have contributed to. But it's also a lot bigger than probably most open source projects that you've ever worked on. And so, the learning curve can be high, both in terms of technical knowledge and in process and rules and stuff like that, but it's definitely worth it. And even if you never have any intention of actually contributing code to the project, really just being involved in, running it, playing with it, and contributing bug reports, and giving us feedback on early access releases. Being that kind of power user that's really on the bleeding edge of what we're doing and helping us, identify any kind of pitfalls that we might not be aware of yet. That's extremely important and extremely invaluable in any open source project, and OpenJDK is no exception. So, just download the source code and play with it, look through it, search through it, study it, and that alone will make you a better Java developer. You'll understand better, and if you want to participate more, by all means, I'm very excited and hope that some of you do decide to do that, and I look forward to working with all of you. So that's my presentation, and there's no time limit on the web conference, and as Bruno said, I guess there's a lot of questions, so I'll try and answer any and all of them that I can.
All right.
Thank you very much for your time.
So thanks a lot, David. It was great. Hopefully, a lot of people just stayed. It was, I think you covered a lot of content right there, and very, very good overview of absolutely everything. I think that's once watching this, a lot of the questions about how OpenJDK works have been solved. But let's go to the questions here, and even some people that couldn't stay, I think they can come back and watch the replay. So, one of the very first questions was about Git versus Mercurial, and so Kevin asked if there was any plans to eventually switch to Git or GitHub for OpenJDK development.
It's something that comes up every once in a while. I really can't give any kind of definitive answer. Although I will say that all of us use Git. We all know it, and we all hate the fact that we kind of have to use both because they're so similar to each other. In fact, it's kind of crazy when I actually learned Mercurial before learning Git because of my job. But when I did learn Git because the rest of the world uses Git, I kept thinking it's crazy how similar the architecture is and the thinking behind them is. And you almost think one of them must have copied the other one. And you go and you look on Wikipedia and it's like, no, both projects got released within like a couple weeks of each other, which is really strange, but they're eerily similar. But the downside to that is that it's very easy to get confused because they're so similar that you kind of forget that they're different systems. And so every time when you're sitting in front of Mercurial, you're typing in Git commands, and when you're sitting in front of Git, you're typing in Mercurial commands, and that's just kind of the curse of being an OpenJDK developer. But we use Git for, internally we use Git for a few different projects. Things like Oracle Labs uses Git internally, so things like Graal, the C1 visualizer tool, things like that are done by Git. So we all know Git, we all like Git, and we all acknowledge that life would be probably easier if OpenJDK also used Git. At the same time, there's a huge amount of infrastructure, an unbelievable amount of infrastructure that is tied to the current Mercurial implementation, and that's not necessarily always going to be a blocker to moving from it, but it is a significant cost to moving off of it. And so I don't, it's a matter of prioritizing, and I don't see it happening in the immediate future. But it is something that people talk about every once in a while, and it's something we'd all like to see happen. But I don't know if, I don't know how soon or if ever we'll see. I mean, I assume it'll happen someday, but I guess one of the problems is that there really is no huge win except, convenience. And convenience is important, but it's not, there's nothing that we can't do with Mercurial that we want to do. So there's no technical improvement by moving to Git. It's really just, well, then I don't, I can swap out the knowledge of Mercurial out of my brain and use that swap space for something else. And that is kind of a hard thing to justify such a huge investment of time and effort to completely rework the current infrastructure to use a new system. I mean, it might happen, but I don't know when, and I'd be surprised if it happened soon. But we definitely talk about it fairly frequently.
Okay, I just want to add that for those that want to take a look at the source code of OpenJDK, and see the projects and even build, but don't intend to do any contribution right now, there are some mirrors of OpenJDK on GitHub, right? So you could actually download the source code from GitHub and take a look there. But of course, as David said, if you want to contribute back, eventually you're going to have to deal with Mercurial.
Yeah, and I mean, for people that are just starting off, the first few steps are really just you don't even do a commit to your local repository. All you do is you generate a web rev, and then you send it to the mailing list for other people to review, and then they push it for you. So you actually, for the first several commits, you actually have zero interaction with Mercurial outside of cloning. That's all you do is you clone the repository, and that's it. And cloning is exactly the same as it is in Git. You just replace Git with HG, and you're cloning. So in that sense, really, you can just ignore the fact that it's Mercurial. As long as Mercurial is installed on your local system, which is just an apt-get or yum command away, it's there, and then you can just kind of not worry about it. Worrying about the source code management system is really something that would come, when you're actually doing your own commits and your own pushes and things like that, and that's quite a ways down the road from where you are if you're just starting. So I would not worry about that too much now, and just as long as you can get the code and make a change that, or not make a web rev, which is completely independent of Mercurial. You have enough to get your changes into the project and get them reviewed. So that should be just easy for anybody who's familiar with Git.
Okay, so Partha asks, he's not sure if the right place, but if Project Sumatra for using the GPUs is still going on, and if it's part of OpenJDK.
There is a project, I believe. Unfortunately, I have to say this is probably not the place because I don't know anything about Sumatra. They've done some really cool. A few years ago, I was at the JVM Language Summit, and there was someone from AMD doing a talk about that particular project. But I personally don't know anything or could tell you anything beyond what's in that video. that's available online and that you've probably already seen. But I think yeah. So it is an OpenJDK project, and so there's going to be a mailing list for here. There's a repository. We can look at the repository to see if anyone's checking stuff in, for example. I assume there's a repository here. Let's go take a look and see if we can find it. So I'm just going to assume either JDK or hotspot. Well, maybe JDK would be. Okay, so this one hasn't seen an update since 2014. Yeah, I mean, looking at this, it doesn't look like there's a lot going on, but again, I don't know anything about this project. Another source of information is obviously the mailing lists. So we could see if we go try and see if there's any activity there. So I mean, this was in August of this year was the last thread, and it was, I assume, someone introducing themselves. So, oh, we can see some Java champions in here, but yeah, I mean, it sounded like a really interesting project, and I don't know, maybe it's somehow progressing outside of the OpenJDK umbrella. I just don't know. But I would suggest, maybe just reaching out on this alias and asking people what's up, or kind of reading through the past couple months of archived threads, and maybe there's people talking about that they've moved to something else, or that something's being on hold, or who knows. But unfortunately, I'd like to give a better answer, but I just don't know enough about that to really say anything intelligent about it.
Well, that's okay. That's okay. So that's maybe not an OpenJDK a question, but Kevin asks, is there any plans on getting statically linked Java environments, maybe using Jigsaw? He's thinking about statically linked Java apps for containers.
I don't know. I know right now there's the Alpine Linux port, which is different, obviously, but that's linking against the Muscle C runtime, which is supposed to help with things for container usage. I guess it's like security / small footprint for containers, but that again is not the same, I don't believe, as statically linking. Again, I think I'm just gonna have to say I don't know.
Okay.
Unfortunately, I don't have a good answer for that.
Okay, so John asks about if everything that is on OpenJDK also applies to OpenJavaFX, but then there was a discussion later on. Some people asking. So John asked if JavaFX list is not an OpenJDK list, because then Alex says that JavaFX is not part of OpenJDK. Can you clarify a little bit on this?
Yeah. So, there's kind of a confused history here because FX kind of had its own open stuff, meaning its own infrastructure. So it had like a separate bug database, it had separate repositories, and all that for a very long time. But at some point, thankfully, it merged. And so now FX is completely under the OpenJDK, but it's just not included in the default build forests. So there's actually a separate, we're looking at the mailing lists here, but if you look at the project, there's a separate FX OpenFX here. There's a separate repository, and there's instructions online. There's build instructions for how to pull one of these kind of mini FX, runtime trees into your OpenJDK build environment, and to have that built along, so you kind of end up with a combined JDK that has the OpenFX classes or the JavaFX classes as well. So the answer is OpenFX is JavaFX is OpenFX more or less, which is part of OpenJDK. It's just not conveniently downloaded and included in the main forest by default. There's a few extra steps that you have to go through to sync out the runtime, the FX runtime repository that corresponds to whatever major version of OpenJDK you're trying to build. And yet then you have to build that stuff together. I'd also add that FX is a little more complicated to build than OpenJDK, just because of all the links to all the GUI stuff so there's a lot more kind of native stuff that you're linking to. So sometimes getting all the prerequisites in place for setting up a build environment is a little more complicated than just doing the generic OpenJDK build. But again, it is all documented and it's all there.
Okay. All right. So John also asks about if there's a bat file for Windows instead of shell script. And then there was some discussion about using the Windows subsystem for Linux and things like that. But the question, I think, I'm just kind of more generic question in terms of building OpenJDK and contributing to OpenJDK from Windows. Is that any preferred methods?
Yeah, definitely use Cygwin. That's the best advice I can give, because that's what we do. That's what we know works. If the Ubuntu on Windows or whatever that thing is that Microsoft has, that's really impressive and great, but we're just not using it as of today. And I have had some success with building stuff on it, but it's certainly not something that I would rely upon or want to be messing with if I was new to OpenJDK. It's really just a lot easier to kind of take that away as a variable in your early experiments, and just kind of do things the same as everyone else, and everyone else is using Cygwin for building OpenJDK. So I would start with that, and then if you're interested, try doing it on the Linux for Windows subsystem or whatever they call it. I mean that the Linux for subsystem, the Linux thing for Windows it's kind of amazing what works under it and how good of a job they did putting it together. So it would not surprise me if more and more people actually did start doing stuff under that. But as of today, the standard is Cygwin, and if you're just starting off, you're just gonna kind of not hit certain possible issues by kind of sticking with what everyone else is using. So that would be my advice.
Okay. All right. Cool. So Alex had a question here. Oh, sorry, I misplaced his question. So his question is, will enable debug automatically build the disassembler libraries required to do code gem prints for C2?
No. So the issue there is that the current implementation, which is known as HSDIS, is more or less built or designed around binutils. So the binutils disassembler is really stable and it works really well and everyone likes it. And so John Rose, a number of years ago, wrote a wrapper library around it that's just basically a really lightweight interface between Hotspot and the binutils disassembly implementation, and that allows us to crank out disassembly from anything, from C1, C2, the template interpreter that we generate at startup, native method, adapters, all that stuff. You can get disassembly for using the HSDIS wrapper. But the problem is that the OpenJDK is licensed under the GNU Public License version 2, whereas in BinUtil's project has moved to GPL version 3 quite a while ago. And those versions are not compatible, interestingly enough. And so technically we can't include BinUtils and use it directly ourselves. So for example, we're not allowed to make the BinUtils plugin, the BinUtils based plugin for Hotspot and distribute that. Because that would be a violation of the GPL version 3 license. The GPL version 3 license would require us to also release Hotspot as GPL version 3 because we're linking against it. So basically, because of licensing issues, we can't just do all that stuff and include it automatically. But HSDIS is very easy to build on your own. And you're not, if you're doing it on your own, you're not violating any licenses by just, downloading BinUtils and building the plugin yourself. And that's very easy to do. And for example, I have done that under the Windows build system, or the Windows Ubuntu thing, by the way. And it worked very well. So if you need that plugin, you can just do it. You can build it yourself and use it. There's tons of instructions online. And we're also looking at, there's an open source project, I believe, called Capstone, that's also a disassembler. And it has kind of like a much more lenient license, something along the lines of like a BSD or Apache type license. And so if we were able to use that for our disassembly, then there wouldn't be any license issues whatsoever. So one of the issues on my to-do list is to look at porting our disassembly infrastructure from the BinUtils-based wrapper, the HSDIS tool or wrapper, to the Capstone project, so that we don't have licensing issues like this, and we can just kind of make stuff work out of the box. But unfortunately, today you have to manually download BinUtils and build it yourself. But it's super easy to do. The instructions are all right there. On Windows, it's a little bit of a pain in the butt, but all the other platforms, I've put a lot of effort not too long ago to actually make sure that the make files work for kind of all the standard platforms that we support. So especially if you're running on Linux or Solaris of any kind, it's just a matter of download BinUtils and run make, and you'll get the plugin and you can use it.
Okay, David, look, I don't see any more questions. So, if anyone has any more questions to ask, that's the moment. But I think it has been amazing. Let me turn the camera on here just so you can.
I'm gonna stop sharing.
Yes. Okay. So. Yeah, so thanks everyone. I don't see any more questions, and it has been an amazing deep information. People did comment here. There's so much info and very inspiring. There's Kevin did a comment here that this whole stuff is just so archaic if you're used to GitHub and such. He was like a smiling, but then he said, but very interesting to look behind the curtains. And I think you've mentioned already a little bit. And those are long-term decisions taken long ago. I think that's a good. So Kevin says 2 a.m. in Germany, so he needs to go to bed. Right? Thanks a lot, Kevin. Thanks for being with us for so long. So thanks everyone. So Rodrigo says great session. Thank you. John says truly awesome presentation. Thanks. So any parting words, David?
Just thank you so much for letting me do this. I know it was extremely long-winded and verbose talk, but I really think that, I think we needed to go into this level of detail for people to be able to kind of jump into things on their own. But again, please, if you're considering participating, don't hesitate, reach out, talk to us, get involved. We'd really, really love to have more people join us and kind of partake in the fun. So thank you so much for listening and letting me do this.
So David, there's one more. I think there was a comment here somewhere. I couldn't find it on the chat, but someone was asking if there would be some more sessions like this, that you would go into more details of different things. So I'm going to invite you, and I know we talked a little bit about this, but let me invite you here for us to keep doing this, and maybe we could do from time to time. Like a open JDK session where we can go, and, some more specific things. So, we're open here. Anytime you want to do this, I'd love to do this again with you.
Yeah, I'd really like to do a more technical session. Kind of less policy and rules and more nuts and bolts. So, yeah, let's set something up offline. I'd really love to do that.
Sorry, I mute myself here. So, all right. So that was great. And everyone for joining us here, reminding you that there's 2 more sessions tomorrow. Tomorrow we're going to have Elder Moraes, and he's going to be here talking about FN. There's going to be I kind of forgot the name of it. He has a guest actually, and tomorrow and on Friday I have Ruslan Sinitsky from Travis. Thanks Rodrigo. So Travis from it's an Oracle architect of FN. So he's going to be here tomorrow with Elder Moraes. They're both going to talk about serverless and cloud, and how cloud and microservices and serverless will define our future as developers. And on Friday we have Ruslan Sinitsky from Jelastic, and Rodrigo Moutinho from the Cyborg Developer Project, and they're both going to talk about how you can work Java EE and containers together, VMs to containers, migrating legacy Java EE applications. So hope to see you guys there. And thanks once more, David. Thanks for your time. And we're gonna keep in touch. Thanks a lot.
Thanks. Bye.